Okay, so today I'm going to be working on a board for the sales guy here. He bought a machine and it doesn't turn on. And I actually owe him a board because one of his boards got sodomized by somebody who used to work here. That was an 820-3330. This one is a 2936, so we are not even close to calling it even if I do fix this. So the problem is that it doesn't turn on. You don't get a green light in the charger. So as you can see, I plug it in, no green light, there's no fan spinning. I guess maybe you can't see at that camera angle, but you could take my word for it that it doesn't work. Not much reason for me to lie about something not working. So let's get the multimeter on the table here. Let's do some measuring. So where PP bus G3 hot is supposed to be, I get 12.24 volts, good enough. Where PP3V42 is supposed to be, I get 3.42 volts, good enough. There's no green light on the charger, and there's also no PP5VS5. Let's see, obviously if that doesn't exist, we're not going to see PP5VS3 anywhere here. So we can just might as well stop checking. Let's check out what the one-wire circuit's talking about, shall we? So I'm going to open the schematic here. I'm going to might as well show you that on the screen. Let's see if I still have the numbers memorized. Almost. I don't. Oh, here we go. I do. For a second I thought I had it memorized. Alright, so let's see if we're getting SMC BCA HAKKO over here. This is supposed to be coming from U7000, which is going to tell this to allow the green light to go on when it talks to the SMC. So let's see what I have on SMC BCA HAKKO, which is supposed to be pins 1 and 2 of U6901. So we're going to open a board view software here, which open file, we're going to open. Sounds like somebody's murdering somebody inside my bathroom. I'm pretty sure that it's the exhaust fan I put in the window falling down in over itself. Yeah, my construction, if you even call it construction, there's nothing to trust. If I do it myself, God help you. Okay, CU6901, pins 1 and 2. So what do we got here? So over here, let's see, is that pin 1 and 2? So pin 1 and pin 2 are supposed to be, those should be higher than what I think I'm going to get. Let's see. I get 0.589. Nah, not good enough. Alright, so let's see if there's any problem or a short to ground along that line. I'm expecting more than that. You also didn't see me just measure that part of the board because I forgot to turn open broadcaster back to the screen. I'll do it again for your benefit. So might as well show you what I'm measuring to on this camera here. Try to do it without destroying my setup. Moving this microscope back and forth is not making it happy. So let's see, I can put this above, and I can do this, I can do that, it's pretty freaking cool. And I can do this, here we go. So. Some pretty cool shit, ain't it? So first let's check for the short to ground. Get the red probe on ground and the black probe on top of it. Pins 1 and 2 right there. Sure, that's not diode mode. There's diode mode. See, that ain't no good. So something's shorting my SMC BCA HAKKO to ground. Now it could either be this chip in the one-wire circuit here. Let me just go back to the schematic so that you can see. We're going to go screen quarter. So it could either be this U6901 chip, which, come on, mofo. Where's my hand tool? Here, give me hand tool, hand tool, hand tool. Render faster, you fucker. Okay, so SMC-BCA cock goes to U6901. That could be shorted to ground. That U6901 could be. Or it could be ISL6259. So the way this works is ISL6259, which is U7000 on the board, controls the charger. So this is responsible for the charger going through to the machine. When everything is good over here, when this circuit is working properly, and the charger, which is 16 or 18 volts, is going through this buck converter to make 12.6 volts for the machine, and all is happy, it sends out SMC-BC ACOK, which I have been calling it ACOK because, frankly, it sounded funnier and I was being immature. But apparently that actually stands for ACOK. Again, we live in a world where there's no documentation for any of this stuff, so you just kind of have to guess until somebody tells you otherwise. So that signal is supposed to be about 3 volts or so, and it's shorted to ground. In addition to it being shorted to ground, it's also the voltage is too low. So I'm going to start removing things and see if my short to ground for that goes away. I'm going to start with the U7000, because that is what goes off bad much more often on here than anything else. On older boards, that little IC that I showed you actually goes bad more often because it's in a spot where the water for some reason just winds up going. Even though they're both on the edge, I'll show you it again on the microscope camera here. Yeah, so this little thing. On the older boards, this is usually over here on the Core 2 Duo base boards. And because it's in that location, that's always what fucks up due to water. Now on the newer boards, this here for, I believe, don't quote me on it, as high side current sensing, that often goes bad because it's right in the area where the water goes. And don't ask me why the water always goes to that area, it just so happens to be that way. So I'm going to remove U7000, and we're going to see if that's the problem. Again, this is a little tricky. And the reason it's tricky is because this chip here is actually creating the voltage it's supposed to. So it's allowing the buck converter to create the 12.2 or 12.6 volts from the charger. So this is one of those boards where you have to have a little bit of experience to know what's going on, or you're going to be a bit confused. Now, as I've said in the last video, I believe my FR801 needs a heating element replaced. Because I'm on 8 right now. I mean, if any of you guys who have an FR801 know, 8 is way too high for any of this work. It's really not what you should be using, and I'm still not melting a damn thing. I got the airflow on 12. Like, usually I'm doing this at 6.5 or 6. I just haven't had the time to call HAKKO. You know, one of those things where, you know, I want to call HAKKO, but a customer walked in. I want to call HAKKO, but I have to do an estimate on for some kind of install at a new building that wants something done. It's always something. I've gotten used to and accustomed to the fact that, that I have no free time. Okay. Okay, we're gonna get a dead board. Dead not because the ISL is bad, but dead because it has a hole drilled in it. A hole poked through it. I don't know who the hell decides to put the holes in these, but there's a short on the pads in the bottom right corner, but that'll get fixed later. It's important to remember the orientation of the chip. Obviously, if you put it on the wrong way, it will smoke. That's nothing bad on top of the chip. It looks burned. That's actually, there was a little bit of label paper on it that said what this board was. I didn't peel all of it off, and then I burned it when I was removing the chip. That's not a burn on the chip. That's a burn on the paper that was sitting on top of the chip. Disgusting soldering. That is gross. That is bad. That is bullshit, right? I like having the pointy tip because I can actually feel when I'm pushing against the both the pad on the package and the pad on the board. You can feel when you get in the groove and indent in there. Okay. Move away the flux so I can see what I have. I'm happy. Alrighty. I left my brush in the front of the store again. God damn. I don't want to use a Q-tip. Why do we always have this unlimited supply of Q-tips in front of me? Man. Alright. Didn't leave any... I think I managed to not leave any junk behind this time. Alright. You know what I forgot to do? You know what makes me a moron? You know what makes me a real idiot? I forgot to check and see if the short was gone from the board before I put that thing back on. That makes me pretty dumb, doesn't it? But lucky for me, it is. You can't see that, can you? Can you? Well, I don't have to do an edit in Vegas. I don't have to do an edit later. I can just resize that. This is what I love about this new editing platform. I mean, this new recording platform. That would have been an edit from a transition earlier. Now it's just me resizing from a real live encode. So we're going to go over to that same part of the board we were at before. When we measure for a short to ground, I don't have one. So that was 0.021 before. That was a 0.021 voltage drop to ground. Now it's a 0.424 voltage drop to ground, which means that we're probably not short to ground anymore. Which means that Steve's board works, which is beautiful. Hopefully it works, because if it does, I'm part of my way over to not owing him a 3330. And no green light. Boo. Okay, well, we made some progress. At the very least, we know that that damn thing. We made some progress here. Still 0.555 volts on there. That's really weird now, because there's no more short to ground. So why is SMC BCA cock still low? Huh. That's a head stumper. Okay, so R5087 is the pull-up resistor. Let's look for R5807, shall we? R5087. Whoops. Go figure, it's on the other side of the board. Ah, I just poked myself in the thigh with the multimeter lead. I'm surprised it didn't go through to the other side. Damn, that is some nasty, dusty crap. So that up there is the PP3V42 side of the resistor. .3, other side 0.5. Let's make sure that resistor is the proper measurement. Go back to resistance mode on the multimeter. That's blurry, but whatever. Whatever. So 280 kilo. Actually, let's see. 1 kilo ohm, 2.3 kilo ohm. Oh. Losing patience. I hate holding that thing there and waiting for it to calculate resistance. Let me at least make that look better in the meantime. .500 kilo ohms, 600 kilo ohms, 500 kilo ohms. See why I use diode mode for most things? Like, I don't have the fucking patience for resistance mode measurements. 473 kilo ohms is what we settle on. Schematic says you're supposed to be 470 kilo ohms, so you're not the problem. Let's measure the short, if there's a short on there again, just because I'm... No short whatsoever. If I were to just put some voltage on there, what would happen? Just curious, just curious. That's the way we learn. Yeah. You may be looking at what I'm doing right now and thinking that's retarded. Why are you doing that? That's dumb. Where do you think I learned all of this from? I mean, like, you think I just went to online and went to like the Apple store and just bought the book in their Barnes and Noble section entitled, component level motherboard repair? Like, no, it's experimentation. I don't know how the fuck any of this shit works. I'm sure Steve will forgive me anyway if this leads to horrible consequences. Okay, that is one of the worst soldering jobs that you can possibly do. I mean, that is... Like, really, look at that. That's garbage. But that is purely for testing purposes. And... yeah. Get the ground attached here. Yeah, everybody who works here knows that if they give me something like this, they know what I'm doing to figure it out. They know what I'm doing to fix it, and there's no surprises. That's the thing. We're all on the same page with that kind of thing. So I mean, he knows that I'm hooking this up to wires and doing strange and crazy shit to figure it out. He knows. Like Steve, he knows. Point 2. Okay. I put power in. I get a green light. Interesting. So you can see it. And the fan is spinning. I turn it off. On the power supply is now turned off. And still green light. Let's try that again. So unplug the charger. Plug the charger back in. Nothing. No green light. Nothing. Bullshit. Jiggle it a little bit. I got nothing. No green light at all. I turn the power supply on again. Current to 0.2 amps. Okay, we don't want to blow anything here. Like this, the purpose here is not to make things hot. It's to... And the fan turns on. Okay. What is SMC BCA HAKKO if I actually remove U6901? That's going to be the next thing. So if I didn't show you this already, so we replaced U7000. Let's see. Yeah, so we replaced U7000. Now let me just take off U6901. I'm just kind of curious what happens here. Wait a minute. So first, let me remove my little cluster of a jumper wire here. So at least the thing is, the rabbit hole is not that deep. I mean, the machine has the capability to turn on. Soldering iron. Hello. Are you hot? Okay, you're hot. Now melt you. There you go. Just sitting there and it wasn't melting shit before. Okay, let's say something in this side is just screwing it up. Now if I take this off and I plug it in, am I going to get 3.3 volts on SMC BCA HAKKO? No, so by the way, you're going to say that I damaged those upper two pins? They're soldered together on here anyway, so. This just does not heat the way it used to. See a little capacitor that moved over there? This sucks. I also don't want to open up my iron. I know this is silly, but I have a really big pet peeve about repairing tools. I hate repairing the items that I need to use to repair items. I mean, like, knowing that I have to come to work is already something. So, I mean, I know that I have to come to work, and I know that I'm going to have a lot of junk to fix that I don't know how to fix, that there's no manual for. But then knowing that I have to fix my tool just so that I can get to the work of making money, there's something about it that's just so fundamentally discouraging and irritating. I know I'm just bitching for over nothing, but that's just how I feel. I hate fixing tools. Fixing tools is ugh. So one of the things you may have noticed while I was scrolling back and forth there is that SMC BCA HAKKO also goes to the SMC. So if it's being sent to ground, the SMC can also be to blame. Another thing here that's really silly is I actually removed one of the components required for having a green light. And as you can see here, I had a green light for a second. It was dim. Where's the microscope? Yeah, see that? This is silly. Anyway, so one of the things I'm going to do now, I'm going to measure on the pad where SMC BCA HAKKO is, and you know, let's see what I get. Just put the multimeter, you can actually see it. So you'd have to be in this room to understand, but the reason I look dark and there's so much light around me is there's so much light above me in this room. I have 1,200 LEDs above me here, 1,200 LEDs above that table, and 1,200 LEDs above that table. I mean, it is a little bit overkill, but I like having light where I can see everything. Alright, so when I plug the... Let's see, when I plug the charger in, I'm going to measure where SMC BCA HAKKO is supposed to be. And I get 0.5 volt. Motherfucker. Alright. Let's... Grr. Alright. I'm going to remove that U7000 just in the case that it was bad. And I did take it off of a questionable motherboard. The only thing at this point that could be pulling that down is the SMC, which I don't want to fix an SMC tonight. The reason I shy away from doing SMCs on camera is very simple. Firstly, you're reballing a chip with 0.3mm balls. I mean, it's at a point where the balls themselves are so small that even when you get a stencil that's made for it, it's very easy to get 2 balls inside of one hole in the stencil. The second thing is that it's a pain in the ass BGA procedure. The third problem with it is that, above all, and this is the part that I really hate, is you do it all, but you're taking the SMCs off of boards that look like this, right? So the problem here that people don't understand is that I don't know if this is good. This board has a hole in it. This is the only place that I can get a programmed SMC is off of another board. Now this board was thrown in the garbage. This board is probably thrown in the garbage because it doesn't work, and there is a very, very good chance that this board didn't work because the SMC was bad. So, you know, you do all that work. You're not even 100% sure if the SMC is causing the board issue. Let's face it, sometimes you could be wrong with the board level diagnosis. You don't even know if that's what's causing the problem, right? And then you are forced to test your theory using a part that you don't even know if it's good, using a process that is miserable and very prone to issues and failure. So, I mean, you know, like you want to talk about not wanting to get involved in miserable nightmares and rabbit holes. The SMC is pretty much at the top of that list. Like, that's why those go to the bottom of the pile. I mean, like real, legitimate bottom of the pile. So I'm just going to put the ISL that was working back on. Wishful thinking on my part that it be something but the SMC. I always tell you people not to follow wishful thinking, but then I do the same thing, like, oh, it's going to be the ISL of the one-wire chip. And yeah, well, I'll troll people with that, like, why do you think it's the LCD cable? Why do you think it's the hard drive cable? And it's the same thing every time. It's like they just think it is. They have no reason, no basis, no experience, no anything to pretty much validate their opinion or their theory other than wishful thinking, which is I really want it to be that because I don't want to do the work of the harder job. I don't want to pay for the more expensive part. It's all wishful thinking, and wishful thinking is bullshit. You know what else is bullshit though? You know what else? You want to know what else is bullshit? SMC. Okay, so we will take let's go for a before I remove it, I'm going to do a Hail Mary of reflowing it. I know. I'm just being silly. And wishful. Whoa. Kester 951 on the hands. No good. I didn't use that syringe for a while. Okay, quick. Yeah, there's no waiting there. That stuff is poison. I wash it off as quickly as possible. Do not let Kester 951 stay on your body for a second longer than it has to. So my office is right next to the sink. If I get any of that shit on me, wash it off. Alright. Syringe is a pain in the ass sometimes. Okay, but anyway, did that. So what I've done right here is I shorted the 3.42 volt power supply to SMC BC HAKKO and SMC BC HAKKO VCC. What this is doing is it is completely undoing the one wire protection. only temporarily so that I can actually see what else is wrong with the machine. I want to run it and see, you know, how much of a nightmare it's going to be. Does the rest of it work? Because if the rest of this thing works and it's just an issue on that one part of the SMC, I'll totally put a new SMC on here. But if it's going to be a complete and utter nightmare, then I'm not. And you know, that's one of the things that's important. I like to look ahead and see, you know, is there a light at the end of this tunnel? If I fix this problem, is there going to be X, Y, and Z problem? And you know, if honestly, if this thing works and just needs an SMC, this is a 2011 machine. I will happily give this to Steve and tell him, Steve, here's the stencil, here's the jig, there's the Zalmo. Have fun! But if this is everything else, then screw it. See, this is one of those things that's not fair when you owe people something, and this is something that really deserves its own video to talk about. Everybody has this idea. Everybody has this idea that, you know, let's say I owe you $300, right? And this is actually one of my best friends who I get along with, who owed me money. So he owed me about $250. I loaned him it, and he had a session that he needed help with. So he says, you know what? I'm going to help you get back your $250. Help me with this, set up this session, and I will give you the money or the proceeds from it, you know, if it goes well. So in order for me to get back my money, I had to help him get his money. And I like him. He's a good guy. I'm not saying that he's a bad person. I'm not saying that he did something wrong at all. I'm just saying that this is kind of how people are wired. It's like, you know, help me, help you kind of thing. And I'm, you know, and again, I'm about to do it right now, because if the rest of this thing works, I am giving this back to Steve with an SMC stencil and saying, you know, have fun. Well, let's put this in a machine and see if it has any chance. Oh, by the way, just this should be obvious to all of you, but I know that this channel has a lot of new people on it, so I need to make this very, very clear before I go any further. What I did is I bypassed the one-wire protection only temporarily. This is not something you can ever do. I mean, never, ever, ever fucking do if you're fixing a computer for a customer. This is not something you can ever do if you are reselling a computer. This is not even something that you can do if you're literally just giving it to somebody else in your own facility just to test or just to play with. This is something that is you cannot do that. You're bypassing the protection that Apple put there on the charging circuitry. This is purely for diagnostic purposes right now. This is not something that you can ever do to somebody else's machine. This is not something you can ever leave in somebody else's machine. You cannot call this fixed. You cannot give this back to somebody. If it blows up, they can sue you. I mean, this is serious. I just need to make sure, because, you know, I like to joke about a lot of things in this channel, and I like to show you, you know, my procedures, but this is something where you really need to understand where I'm coming from if you are going to emulate any of it. You know, you cannot give back somebody a computer that has one-wire circuitry missing. You cannot bridge things. You need to fix the problem. Here, I simply want to see if it's worth it. Again, like if this machine has a CPU or a PCH that's burned out, it's going to go in the trash. But I want to make sure that the rest of this thing works before I go about sending myself or Steve on a 1 or 2 hour mission to get the SMC working. Because that's not even an hour of regular labor, it's an hour of miserable labor. You could go through 4 of those fucking things and not find one that works. Or you could find one that works, but mess up one ball in the soldering job, or the ball is over here instead of being over there, and no SMC for you. Ugh. Fuck that noise. And like when you have SMCs coming off of boards that look like this, like, well, what's the confidence level, you know? You know what I'm saying? See what they did to this thing? See that? See this? Like this port that's like hanging off of it. I mean, I really sometimes I think that these boards come from, and I really think they come from people in other countries who just hate Americans, who just take a baseball bat and just beat the shit out of them. Because again, there are ways to actually remove the chips from the board without sodomizing it. I mean, there's a way that you can take the CPU and the RAM and all of that off of that board without sticking holes in them, without bending them and bashing the ports. I really think that they're just bashed because they just want to make my life a living hell. That's my only working theory here. It doesn't work slow. It charges the battery. It sees the battery. It's really just that one part of the SMC that's malfunctioning. So what this board needs is an SMC replacement. So you got to see how I diagnosed that it needed an SMC replacement, and you got to see that you got to see what the SMC does in that part of the charging circuit, and you got to see at the very least some partial functionality. Now, again, one of these days I am going to put an SMC video up. Today's not it, because again, it's just so like again with the graphics chip BGA video, at least like I'm done. I'm taking a chip that I know has a reasonable chance of working and putting it onto a board. If I am not taking graphics chips off of dead boards, hoping that one of them has a good graphics chip, and then like I just no fuck that shit. That is a video for another time, but at least you got to learn something. And one of these days I will put up an SMC video. Again, one of the things that kills me about doing the videos and doing the board repair is that it slows down my workflow. And when I'm doing something that I know is going to take 1 or 2 hours already, I'm not slowing down my workflow. I need I need like my Southern Comfort. I need my music. I need no wires hanging from me and for everything to be off. And then I'll go into a room with a stack of 4 or 6 boards that hopefully one of them has a working SMC on and do it. But yeah, that's about it for now, and see you later. And again, remember, don't bypass the one-wire protection. Don't be an asshole. Don't be a douche. I feel like I really do feel like I should not even be uploading this, because I know you people out there. I know you people who don't know how to sell your customers. I know there's people out there who don't know how to sell people on waiting a couple of days for you to order whatever you need. And I know there's some people out there that frankly they just don't want to learn how to do what's proper if they can just put a little wire there and be set. Don't do it. Again, if you do that, you deserve to go straight to hell. If you bypass the one-wire circuitry, you deserve to go straight to hell. And that's really all there is to it. Don't bypass the one-wire circuitry.